I was in the middle of uploading this video or recording this video, and then it stopped. So there's a lot of stuff I already wrote on here, so I'm just going to try to go through and explain it. So the purpose of this lesson here is looking at patterns that quadratics have in terms of their values and their growth and their numbers. And so the situation here is that you're standing in line at the fair, and over time those lines are going to get bigger and bigger. And so each block that you see represents 1 square meter of space standing. And so you can see that at each stage the number of people waiting in line is getting longer and longer and longer, and that's going to continue to happen. All right, now question number 1 says, what patterns do you notice? So I started by just what a lot of students will do, which is just count how many blocks there are. So there's 2 blocks, 5 blocks, 10 blocks, 17 blocks, 26 blocks. And then I noticed that, okay, the number of blocks that's being added is increasing by 2. So it's not the same amount each time, which is what we learned back in Unit 1, back in Math 1A. But this is just adding 2 new blocks each time. Okay, so that's what I said here. The number of blocks added increases by 2 each new stage. Okay, and then the next thing I talked about is looking at pictures and noticing that this middle square is getting bigger each time. There's like this middle square. And then, of course, there's this top piece as well, and bottom piece. But the middle square is kind of what I'm focusing on. And so I said, well, the middle square grows by 1 block dimension-wise. So that's the key part, dimension-wise, each time. So the dimensions here are 1 by 1. This is a 2 by 2, 3 by 3, 4 by 4. So 4, not a 9. All right. And so you can see kind of what's happening with the square. Then I talked about the number of blocks on top and bottom. So there's the same number of blocks above and below each square. And so I said that. And also that it matches what the stage number is. So at stage 2, it's 2 and 2 on top and bottom. 3, stage 3 is 3 and 3. Stage 4 is 4 and 4, so on. And then I also mentioned that the middle square size is 1 lower than the stage. So, my example was here at stage 4, this square in the middle is a 3 by 3. It's a 3 by 3 square. And then at stage 5, it's a 4 by 4 square. All right, so that's kind of where I left off, and then the video cut off. All right. Now it says, is there a linear relationship between the figure number and the total number of blocks? Why or why not? So in terms of a linear relationship, remember linear means that it's growing or decreasing or decaying by the same amount. So that's what linear means, linear. So we're looking at our situation here. And so at stage 1, there were 2 blocks, stage 2, 5, stage 3, 10, stage 4, 17, stage 5, 26. And I can see that it wasn't, from what I did earlier. Sorry, I was creating this table, my bad. All right, so I just created the table for the stage number and how many blocks there were, because that's what I'm looking for. This is the total, and this is the stage that we're on. So stage 1 and the total there. And I can see that it's not linear. These numbers are not the same. And so it is not linear due to that. It's not linear because this is not the same each time. Okay. Now, what we're getting into though is something, and we're going to use some terminology here. This is not linear because the difference is not the same. Each or same between each stage. All right, so that's sort of our noticing moments here. What we've noticed, what we've understood, is seeing that this is not the same. All right, this is called the first difference between these. So that's kind of what our goal is, understanding that. And then what we are seeing, though, is that it is growing by 2 after that. This is the same, but this is called the second difference. So we are noticing that this here is the same, but this is called the second difference. And this second difference is the same, but it's still not a linear function. For a linear function, it has to be the first difference being the same. Okay, so that's something that we do have to understand there. So the answer to the question is it's not linear because of this. Okay, so that's sort of our situation. All right, moving on to here. It says sketch the next figure in the sequence. So, I think you guys can sketch that at stage 6. You just have to sketch kind of what's going on there. I'm really not going to go through and redraw this whole thing, but based off of what we talked about. So at stage 6, I do know that in that middle square, it's going to be a 5 by 5 square. And then above it, it's going to be a 6 here. And then there's going to be 6 there. All right, and then, well, if I can draw the picture right, it's supposed to be longer on this side. Okay, there we go. All right, so there's gonna be 6 in this, 6 in this, and this is gonna be a 5 by 5, which is 25 of those. And so the total for this would be 25 plus 2 times 6. So 25 plus 12, 37 blocks would be in this stage. Now determine an equation for the total number of blocks in any figure in the sequence. Explain your equation and show how it relates to the visual diagram. All right, so I printed that out again because I don't want to keep flipping pages, but going through what we did. All right, so I just printed the page again because I just didn't feel like flipping it back and forth. All right, so what we said, and you want to create an explicit equation. That's the goal. But I'm going to talk real quick about the recursive. So the recursive is a tough one because remember it was that we are adding 2 new blocks each time. So it's not a constant rate there, not a constant common difference. And so, recursively, this is kind of difficult. But the way that I can look at this recursively, is that I am adding, so I need to come up with an equation for this first difference to be able to do that. So recursively, this is gonna require me to do a few things, and I do think maybe at the moment that's probably not what we're gonna worry about recursively, because the fact that this is changing each time. Maybe when we get back from this whole thing, I can talk about that a little bit more. But the easiest thing there is to do an explicit equation. So that's what we're going to focus on. I was sort of having a moment in my head as to should I go recursive or should I just stick explicitly? And I'm going to stick with it explicitly just so we can go through this. All right. So remember explicitly, and I'm going to use n for the number of blocks. And n is my, not n for the number of blocks, but f of n for the number of blocks. N is my stage number. So depending on what stage I'm on. So when I go back to this picture, I'm going to use sort of that concept that I had with the picture as to how to create this explicit equation. All right, so I'm gonna start here because it's easier to see the picture than it is right there. So again, remember this is a 1 by 1 plus 2 rows, 2 rows with 2 blocks in it. This is a 2 by 2 plus, and then there's 2 rows of 3. Keep moving this thing up. I don't have a tripod for this. And then this is a 3 by 3 and so on, plus 2 rows of 4. Now, going back to this, it's a 0 by 0 square plus 2 rows of 1, right? There's no square in the middle here. So if this is my stage number, if this is n, I need to relate what is happening to n and how am I getting these values in here. So the 1 by 1 at stage 2, the size of this is 1 less than this. So if n is my block number, then if I say n minus 1, this stands for the stage minus 1. So this is n minus 1 on this side. And then there's another n minus 1 right here. This is an n minus 1. This is an n minus 1. And this is an n minus 1. Just for this side right here. Now remember, n is this number there. So this is 5 minus 1, 4. And this is a 4. This is 4 minus 1. This is 3. This is 3 minus 1, 2. This is 2 minus 1. And then there's not really 1 in there, but somewhere in between here, we would say n minus 1, but 1 minus 1 is 0. So that's where I'm getting these things, n minus 1. So n minus 1 is the length of the side of the square. Now, to get the total number of blocks, I need to multiply this side times itself. So this times this. So when I go to my equation, and actually I'm gonna just do the work down here real quick. So if this is n minus 1 and this is n minus 1, then to get the total number of blocks that would be in that, it would be n minus 1 times itself. All right, I can go back up here to this picture that I had. This would be 6 minus 1, which is 5. All right, so this is 6 minus 1, and this is 6 minus 1, which is 5. And so for every picture, this is always going to be represented by the stage number minus 1. Okay, so that's kind of how those square pieces represent. So the stage number minus 1. But I have to multiply it by itself, right? This times this. This is the side times the side for any stage. All right, and this is for stage number, so it's for any stage. Not just one specific, for any stage that I care about, okay? So that's what this comes from. And this, I'm gonna just put sort of a bigger parentheses. So that is this first part. This times this gives me that, right? This was 5 times 5, which is that, okay? So let me go like this and show you. So if I do 6 minus 1 times 6 minus 1, that's going to be 5 times 5, which is 25, right? So that's all I'm doing there. The next part is I'm adding sort of this extra pieces, top and bottom. So remember on top, I have 4 here, I have 4 here, I have 2 of those, right? I have 2. So 2 of the 4s. Here I have 2 of the 3s. So at each stage, I'm doing 2 times that number, 2 times that number. All right, 2 times that number. So here, stage 6, 2 times that stage. Well, remember, our stage number is going to be represented as n, okay? So I'm doing 2 times n now. So this equation is going to allow me to find any blocks, any total number of blocks. So this is the total for any stage. And so if I try it out, I know this one had 37 blocks in it. And actually, better yet, we counted this one, we knew it had 26. So if I plug in 5 into this, it's going to be 5 minus 1 times 5 minus 1. That product times 2 times 5. Now remember, 5 minus 1, that's 4 times 4 plus, and then that's 2 times 5, which is 10. Now the 4 times 4, remember, comes from here. It's 4 blocks and 4 blocks. So it's a 4 by 4 square. That's right here, which is 16 blocks right there. So if I just wrote that, 16 blocks there. So that would be 16 blocks plus total of 10, 5 on top, 5 on the bottom. So 26. All right. So this formula that I have will work for any stage. Okay. That's the goal, is for any stage that we want. Okay. So I'm gonna leave it like that. Of course, we can do some other stuff with that, but I'm gonna leave it just like that for this lesson. Okay. Let me see. All right. Now the ready, set, goes. Go with it. Of course. List the dimensions of each square for the ready. A square has to be the same size on each side. So if the area is 144, that means that it would have to be a 12-inch by 12-inch square. So you would say 12 by 12. Okay. So that's what you're going to be doing for that. So that would be your answer. List the area of each square given the side length. So if the side is 11, then you would say 11 by 11 equals 121 square feet. Make sure you put your units, 121 square feet. Okay, here you are matching each pattern with one of the equations on the right. Again, try to do what I talked about with the lesson. Look for these pictures within a picture type thing, and you're trying to relate it to what you see here. Like for example, I can see that this has a rectangle and then a rectangle here. So I can look at it like that. I can see that this has a square. And then it has these little small pieces there. I could see that. So there's definitely some, other ways to look at this. This one, you could also look at it as it's one giant square missing a block, right? So you can draw this as one giant square missing a block, and you could do it that way. All right, so that's kind of what you're doing, and you're trying to match these up to see which one goes with what. And then for the go, you're trying to solve each equation here for x for 10 and 11. That just means get x by itself. And then what I'm gonna do is I'll post the answers to that here using a distributive property. So you're gonna multiply. Okay. Now, oops, this thing keeps trying to focus real quick. So when you're multiplying, I want to show you this one. Remember what we talked about. When you multiply like bases, you add the exponents. So when I do this, I'm gonna do it off to the side, but so x squared times x is gonna be x to the third because you're adding 2 plus 1 to get 3. So when I multiply this, I'm gonna get 12x to the third. And then when I do my arrow to this one, 11 times 3, so negative 11 times 3 is negative 33. This has no variable, so it stays x squared. And so then this would be my answer. Okay. So that's what you're doing there. Distributing, combining like terms. Okay. All right. See you guys later. Bye.